All right, here's an example on chapter 4, stratified random sampling. Okay, example 4.8. Food expenditure per month in 80 relatively high income earnings family. The families are stratified into 4 strata by income. Stratified sample of 16 is taken and the results are as followed. Okay, so we can see we stratified the population into 4 strata. And then we're given the population size, the sample size, and then the data that we collected. Okay, so within, let's say, the first stratum, we have collected 5 data points from the 20 families, and then that would be their food expenditure spending. Out of the 5, sample average is 307, and then within the sample, we have the variance. Within the stratum, the variance is 202 SI square. Okay, so we can see again under stratified random sampling, we divide the population into 4 strata, and then within each of the stratum, we conduct a simple random sampling. Okay, so that's why we have the very simple average, and then we have the variance within the stratum. Okay, let's compare using let's say if we go back to chapter 3, like using an ordinary simple random sampling methods, we look at the entire data set. So rather than separate them into stratums, we collect 16 data. So we take the overall data average. So 5611, which is the summation of all the data, divided by 16. So y bar, under simple random sampling methods, this is about 350.69. Okay, out of that 16 data point, we calculate the S square, which is 1627. Then we can say that using the estimated variance formula, we find the variance is around 81.48. So we can say 95% confidence interval for the average food expenditure is y bar 350.69 plus or minus the bound of error. Okay, so very much like many of you asking the question in assignments, if I asked for the point estimate and ask you to place a bound of error at the 95% confidence level, so that would be what I'm expecting from you. Okay, so this is the point estimate, and then that would be the bounds of error at 95% confidence interval. Or sometimes we say that this is actually the margin of error. But the margin of error would be subtracted or added to our point estimate to construct the 95% confidence interval. Okay? All right, so like this chapter, we use stratified random sampling. So under stratified random sampling, the y bar would be estimated by the summation of these 4 figures weighted by the population ratio. Okay, so didn't write it out. So that would be 307 multiplied to 20 out of 80 plus 339 times 20 out of 80, etc., etc. And then the y bar estimate is 352.71. Okay, so you can see that it's quite close to the y bar estimate from the simple random sampling. What about the variance and the stratified random sampling? We are looking at the variance summation for the y bar. So variance estimate of y bar within each of the stratum would be the sample variance square multiplied to the final population correction factor within the stratum. Of course, we need to divide by the sample size. Add up all the estimated variance, again weighted by the population's ratio square, of course, and the variance summation. Okay, so weighted by 20 out of 80 square, or 20 out of 80 square, or 25 out of 80 square. Okay, so we find the estimated variance. I should have had a hat on top of both of the variance. Estimated variance of y bar under stratified random sampling is only 11.31. So we are more precise with our point estimate because the bound of error or the margin of error is smaller than how we did it using simple random sampling. So I would say that using stratified random sampling is superior than using simple random sampling because what's the reason? Because we carefully implement the population and divide them into stratum, and then within the stratum they are more homogeneous. Between the strata they are quite different with the average. You can see they're quite different. Okay, in that case we could minimize the variance. All right, so I'd like to go back to example 4.7. That is a continuous of the example 4.6. Advertising firm. A PAR survey suggests that the stratum variances are approximately sigma 1 squares 25, sigma 2 squares 225, sigma 3 squares 100. For the three, remember that TV watching example. The population mean is estimated by stratified simple random sampling. The allocation fractions are given by W1, W2, W3. They are all 1/3. So we equally divide them into three strata. In other words, we take an equal number of observations from each stratum. Choose the sample size to obtain 95% confidence bound on the error of the estimate. Now we're given the population mean with bound of error of 2 hours. So now in this case, the B for the bound of error is 2. So we can apply formula 4.9 to estimate or to find the sample size requirement. Okay. Within the stratum, we were given all of the NL, the population size, and we were given sigma square. So we can replace the SL square by sigma L square. And little WL is 1/3. We equally divide the sample size into 1/3, 1/3, and 1/3. We have N square and we also have D square. The bound of error is 2. We also need to calculate or compute the summation of NL multiplied to sigma L square in this example. So let's do that bit by bit. So on top, we calculate the summations. And also for the denominator, we calculate the summation. And then N square, D square. So bound of error, is it referring to the population mean? So 2 squared divided by 4. So 96100. Substitute into the formula 4.10. We find the sample size must be greater or equals to 56.7. Again, we need to round up the sample size to 57. And then we know that for each of the stratum, we equally divide the 57. So each of the stratum sizes, sample size is about 19. Okay, 2, the population total with bound of error 400 hours. So now we are given the bound of error, that is referring to the population total. So in this case, we are using the bound of error is 400 and divided by the critical value 1.96 at the 95 critical value, confidence level. So D square is 40,000. We are referring this to the population total, so we need to use formula 4.10. Okay. So 4.10, we substitute into 4.10, we find the sample size must be at least 104.2, so we round it up again, would be 105. Each of the stratum, we need to collect 35 data points. Okay. Any question? Okay, so under the stratified random sampling, we have just decided on the sample size determination. But in chapter 3, we will stop here because we only need to collect one sample size determination is good enough. But under stratified random sampling, we may need to further develop on the sample size determination for each of the stratum. So think about that. Let's look at this example. In each of the stratum, we would have different population size. Then how do we determine whether we collect more of the sample from the first stratum, which is a larger of the population size, or we would decide the Ni depending on the variance within the stratum, or the cost of collecting the data. So the next section I'm going to talk about is that under stratified random sampling, not only that we need to determine the total sample size that we are going to collect for the entire sample, we also need to allocate that n equally divided by 3 of them, or we would determine the allocation of Ni according to the population size or according to the variability, or determined by the cost of collecting the data. So we will start the next section of the allocation of sample in the next video.